Right, so welcome everyone to week 8. This week we're going to start diving into more cybersecurity related topics. We're going to be starting off with pen testing. As I've mentioned before, a lot of you know that I am actually a pen tester or offensive security engineer by trade. So this is going to be kind of cool to give you some of the insights on, what some of the stuff in the lecture today is, just kind of like what has to be advised via academia, because it's things that you need to know the basics, and then also giving you, some real world insight if I can, based off of some of the topics. And then we're going to briefly talk about the assignment for this week. It's network sniffing assignment, which is pretty straightforward. As I mentioned before we hit record with some of the classes here presently, and if you're watching this, no worries, is the skeleton that you have for this week is pretty straightforward. It has all the code. You just have to write a try statement, which we all know how to write try statements, right? And then give your exception if you need to. That being said, of course, we need to check it out and kind of look at the script and show what it's doing, right? Yeah, so for that, we're gonna go ahead and get going. So introduction into ethical hacking and pen testing. So pen testing, again, something I've been doing for quite a while. It says deliberate attack. It's essentially it's a methodology that's used to assess networks, applications, anything in and there between, to see what kind of potential vulnerabilities and risk are associated with it based off of the security posture, the data within those applications and systems, also who's using them, where they lie within a network, right? If it's a web app server that produces 20% for your bottom line, that's going to be a big risk versus, oh, it's a test system that the developers are using to test out new video games that they're making, and it's on its own separate network. That's different, right? So the goal really is to assess the risk through exploitation. I can't put it any better than that. It's not this like scary ethical hacking thing behind the curtain kind of thing. It's actually more of a business case where folks are actually on both sides of the table talking about what needs to be done, how it needs to be done, and the tactics and techniques that are authorized to be able to use. And that key word is authorized. I really want to make that a focal point. But that's essentially what it is. It's a small to large operation that takes various methodologies and tactics to assess applications and systems to make sure that they cannot be abused, whether it's intentionally or unintentionally. And unintentionally is something that I would really say it's behoove of you to, like, if you want to get into pen testing, to research on that, because believe it or not, systems aren't always made correctly. They can get abused pretty easily, just by accident, especially with automated technology now, where we rely more on the tech than knowing what it needs to do, than ourselves knowing what it needs to do. We're just kind of becoming slaves to it. So it's a big issue, and pen testers are uncovering a lot of new things. So kind of already mentioned this, right? Systems, networks, applications, devices, whole big thing, right? Ethical considerations. Don't cause any harm. So, like, if you're authorized to pen test something, don't just break it just to break it, right? Make sure that you're methodical with your tactics and techniques. Don't ever go after anything if you're not authorized. You'll have like an NDA that you'll sign, typically in an SLA, a service level agreement, that allows you to go test whatever it is that you're going to be testing. You're not allowed to share out any of that information. Again, that falls within a non-disclosure agreement, also known as an NDA. Do not misuse any of that information. Again, part of the NDA. Do not misuse the access that you get. Again, part of the NDA. And take care prior to performing any pen testing to ensure that your actions do not disrupt or cause damage. So make sure that you're not testing at times you shouldn't be testing. Sometimes you're not allowed to test at certain hours. Sometimes you're only allowed to test on the weekends or at night, because normal operating hours are when companies are making lots of money, and they don't want to have something potentially go down, or they don't want you to exhaust any network traffic. So processes, people, and tools, right, create essentially playbooks, or in this case strategy. This is how we do pen testing. You have to have a group of people on both sides, management, pen testers, potentially even like incident responders, the tool sets that you're going to use, which are typically labeled out inside of a pen test report, and then those processes, which also known as methodologies, which is how you're going to go from scanning a system to exploiting it to doing lateral movements to actually creating a report, right? So it's a lot of different things in Synchrony that you do. And but each one of those pillars plays a focal, vital part. All right. So active cyber defense. It's a new concept developed by DARPA and the US Air Force. And this is being implemented into infrastructure. And essentially what this is here and what it has to do with pen testing is you only know what you don't know, right? Or you don't know what, you only know what you don't know. And in this case, using some kind of active defense system, which again is used from people, processes, and tools and methodologies and all that good stuff, you have to have a cohesive detection or defense in order to know how well the offense can stand up against you. If you don't, you can be in a lot of hot water. And you're not going to know, the full security posture of whatever your organization has. By security posture, what I mean by that is basically the vulnerabilities that are within your systems that are exposed. Okay. So asset mapping, right? Detail active and passive mapping of systems, networks, and their normal behavior prior to an attack. Well, you need to know on both sides, right, of a pen test. The defense needs to know where they could potentially get popped, and then the offense or the pen testing team needs to know. Okay, and they need to be able to detect if anything is going on. The deep understanding of cyber resources that you are responsible for, and again, pen test, even in a pen test, both sides are responsible for this, because the data that's going to be collected, the tools that are going to be used against it, which is also going to generate more data, is all going to be encompassed in that pen test. Notice how it says testing, validating, and identifying and understanding any vulnerabilities, weaknesses, and defects in your network systems and devices or processes. So how that's highlighted, right? It's an active defense is used to discover things like that. And we're seeing a lot newer things come out now. We call it purple teaming. Highly recommend, if you haven't heard of that, go just do a quick Google search. It's essentially the concept of doing red teaming and blue teaming all at the same time. So it's become a pretty common proactive tactic used to detect and make your systems better and your overall security posture better. So incident response being another part of this, right? So we've figured out where our stuff is, how to set up monitoring, all that good stuff. Incident response is going to essentially be responding to any issues that potentially happen in there. Rather, it's going to be deliberate, a mistake, false positive, or if it's going to be, like what they call like a P1 or a P2, where there's an actual incident going on and people have to actively contaminate and eradicate some kind of issue that's going on. Could be Trojan, could be an active hacker, something like that. Notice how I say hacker, it doesn't mean that it's a bad guy or a good guy. It could be a pen tester. As someone who does it for a living, can't tell you how many times like I've been moving around in a network and then I get contaminated, and I was the one causing an incident, and it was like a P1 incident where like everybody was all hands on deck and went and essentially isolated all the work I was doing, and that was a lot of fun. So yeah, threat detection and manipulation. Okay, so examining attack methods. This is where you go to things like, if you haven't ever heard of it, the MITRE ATT&CK framework, where you can look up and see how certain actors are acting. You can take logs from your own systems and use that against other folks, or use it against your systems and see like what works, doesn't work. A lot of times, if you work for a Fortune 100 company, you're going to be targeted by known threat actors. And so you can take those techniques and tactics that they're using, go to the MITRE ATT&CK framework and start to map things that they're doing. And then you can even generate your own kind of simulations and you can really go pretty far with it. Notice how it says gaming the adversary. So a big portion of that is where you take, again, like let's say hacker, somebody from some Russian hacking government hacks your company, and you know that their tactics are A through Z. Then you can go to the MITRE ATT&CK framework and you can go look up tactics A through Z instead of 1 through 12 or whatever. And you can create that into a simulation, or as we call it, an adversarial emulation, where you then assign pen testers to essentially act as that threat actor and assess your network so that doesn't happen again. And then threat intelligence consumption, or sometimes you'll just hear it called TI consumption. Interpret threat information and ask critical questions, right? And again, this all comes back to impact. What's the impact? What is the impact? That's really the biggest thing. So why asset mapping? Why is it vital? Well, it's kind of, without even like looking at these bullet points here, the big thing is if you don't know what you only know what you don't know. So if you don't know how to respond to something, if you don't know where something is within your network, within your infrastructure, you're kind of up the creek without a paddle. And when it does get popped, you're not going to know what to do. And by the way, what I mean by popped is if it gets hacked. Should probably disclose that. But excuse me. You have to understand how to operate in it. The other thing is that you have to understand how to make sure that you can detect things and how you can eradicate those, how you can contaminate them, how do you go about that? How do you make sure that you have all the logs that you need so that afterwards you can have a good educational training awareness like kind of seminar to talk about what happened and how it's not going to happen again. A lot of that's going to fall into the next portions that we've already talked about, where you're going to start to say, okay, well, we're going to emulate these things. We're going to do simulated attacks using the techniques and tactics that they used, and we're going to pull it from different sources that we can, because we already have the tactics and techniques that the actual attackers were using. So of course, it says here, right, on a spectrum, vulnerability scanning, pen testing, those encompass ones. Red teaming and cyber hunting are two totally different things. So vulnerability scanning is really just, launching tools that are going to scan your systems and detect vulnerabilities that, a system can. The pen test discovers ones that can't be. And a lot of time it's misconfigurations and logical vulnerabilities, like things that, you have to go through a certain type of process in order to exploit. But they're two complementary things, but vulnerability scanning is like usually the lower end of it. How hacking occurs. So this is straight from the cyber kill chain. So recon is where you perform reconnaissance on an individual or a target, which a target can be an organization or it can be one person. Once you have all the data and you can actually create like a profile or profiles on that target, you weaponize any kind of information that you have. And there's a lot of different, there we could go down a lot of rabbit holes with that. But you weaponize what you're supposed to, you're trying to target. And that can be in the sense of like, oh, I got this person's email and I got like, I know their dog's name, and now I was able to like figure out their password and their, just to the verification for it was what's their favorite dog. So now I was able to do that. And now I can create like phishing emails, to target other people. And then you deliver it. A delivery method is just, again, how you're delivering that payload, right? There's different ways. Are you physically doing it? Are you doing it over email? Are you going to have like a watering hole web server? What are you going to do? Okay. And then exploitation is actively exploiting those folks. Like, so exploiting it would be having the user click on something or having something actually be able to exploit a vulnerability. Installation is the malware actually going on to whatever system it is. Command and control is you being able to control it remotely. And then action is where you actually carry out your game plan. I guess I already said all this. So feel free to go through it. But yeah, I just basically all said this from a standpoint. And like when you do that in a real world, it's basically that you come up with a game plan first, typically. Or I'm sorry, not a game plan first. You come up with who you want to target, and then you come up with a game plan, and then you go through all the steps and say, okay, well, this is what we need to do. This is what we need to do. It's almost kind of like reverse engineering it a little bit. Vulnerability scanning, you don't do that a lot when you're doing like precise attacks in the sense of like a red team engagement, but definitely with pen testing and anything below it, you're gonna look and run tools that are gonna be loud and noisy to find things, and they're gonna discover they're gonna be automated tools, and some of them are even in Python. There's a lot of like command line and terminal tools. You can go on GitHub and just find a bunch of different ones, and those are used to discover vulnerabilities. Is it going to exploit anything? No, they stop before they exploit anything. Pen testing is the next portion that goes on that. You take a look and you assess, you're assessing whatever it is. Whether you can use vulnerability scanners, and then you essentially look at those targets. You say, okay, well, they have this vulnerability and this vulnerability. Let me see if I can exploit these. And if you can, then you see how far you can go. And if you can't, you see if there's another way to do it until you've exhausted all methods. Red teaming is a more targeted one where it's like, okay, we have to get the CEO of Google. How do we do that? And then you go through that cyber kill chain process, and you find a very, very, very straightforward way of finding it, of finding a way to exploit that individual, which is going to involve exploiting a lot of systems, right? And you usually do it from the outside going in. So if you think about it, like vulnerability scanning is like what you do when you have to watch like the Humvee. It's, if you think about it in like a military sense, it's like, okay, you're training to learn how to operate the Humvee, but you're just standing watch and riding in the Humvee. Pen testing is where you actually get to be like a soldier in the Humvee, riding the Humvee around, riding in the Humvee and driving it. And then red teaming is like, oh, you're just like a group of snipers that are, off to go do a mission, and you're, hitting the one thing that you need to hit. So there are some examples. Some of these are kind of old, but highly recommend. If you want to look at some good articles, just go to the NetSec subreddit. That's NetSec, NETSEC, and just go to that. And there's so many different articles out there. I mean, they're actively put out every day. As someone who reads it daily, has an ethical hacker, pen tester, whatever you want to call me, it's definitely something that I would highly recommend. So, so the profile of a pen tester, basic work is to help and defend systems, right? Where a pen tester's job is just to make things better than they were before, essentially. Nothing crazy. It's really like I call it like QA, like quality assurance, but at a very technical level. And it says they typically run standard well-known tests to provide a level of confidence that a system is secure. And so they use tactics that actual ethical hackers would, but they use it in an authorized manner. And a lot of times it's just an quality assurance, like they have access to everything and they know what they need to access, so they're making sure that the apps are working in the way how they're supposed to be working. It says is much more sophisticated in knowledge and possesses specific skills learned through practice. It is something that you learn through practice, but it's a little bit, it's not like we're, I don't like to say the word sophisticated, maybe I'm poaching my own, but like we're just like a pen tester is just someone who enjoys learning new things and tinkering around with things. That's really it. Or at least in this case with tech. They use more advanced tools and help discover more sophisticated vulnerabilities. Advanced tools, I don't know, we can write tools, but depends on the tooling that we're having to use. The biggest distinction between a pen tester and ethical hacker is the ability for the pen tester not only to identify weaknesses, but can also demonstrate specific exploitation of discovered vulnerabilities. Yeah, I mean, again, that goes with the fact of like when you're on a pen test, you have to know what you're doing. And in order to do that, you have to be able to do research. You have to be able to be like, I wonder how this works, or I wonder what happens if I do it like this, right? There's always a different angle. You have different tools that we use, pen testers use. You have different ones for networks, workstations. phones, cloud, let's see, phones, cloud, networks, apps, APIs, all sorts of stuff, right? There's so many different tools, and there's some tools out there that like can assess all, like multiple. Pen testing languages of choice, environments such as PowerShell and Python, provide the pen tested with the ability to craft new tools that address all these certain different things. And most exploits are all wrote, like if you go and you look at a site called ExploitDB, you'll see that most of the exploits are written in either Python, they're either written in Python, C, or Ruby. So a lot of them are written in Python though. A lot are written in Python. So highly recommend you go to ExploitDB. If you're in class now, I'm actually gonna put it in there. You can go to it. I'll put it in resources. I don't know if that did it. I should have. So, and then there's different frameworks that pen testers use because they have to have a method. Frameworks have methodologies and ways of how things are supposed to go. So it's good to have those. If you don't have those, I mean, you might not know what to do, and they just essentially provide a guide map, right, on how to do things. And it does it for anything. Like anybody who's if you've worked in tech or cyber, you know what I'm talking about, and if you haven't, it's something that you're gonna have to do. It's just the name of the game. All right, and then now I'll get you guys set up with the script. If you look at this week's, so with the assignment, you'll need to essentially ingest a PCAP file. Here we go. You're going to need to be able to ingest a PCAP file and read from it. So I posted an article in the material section that shows you how to set up Wireshark. If you use it in the Cyberopolis, you already have access to Wireshark. But if you don't, just install it and attach it to your NIC, which does that at startup. It asks you what network interface card you want to go to. Just go to the one that, if you don't know which one, just look at them, and one of them is going to have a pulse. It literally looks like a heartbeat. That one is the one with network traffic. Literally just go on there, let it run for like 30 seconds, and then stop it, save the file, and then you can use that for your assignment. It's going to need to be in a pretty table like this, because that will, honestly, that's going to help my eyes. It'll also help your eyes. So if you read chapter 3, it was already mentioned by another student that if you read chapter 3, it's pretty straightforward. So if you are getting lost, you know, maybe read chapter 3 if you haven't. If you are still getting lost, make sure that you reach out to me, or also use the Discord as we've been using. And shout out and kudos to you folks for using it. Hopefully it's providing some benefits for you guys. Yep, and notice how it says, note, you're going to need to create network traffic to sniff. So just launch a web browser, do whatever, right? Obviously have it be something that is ethical, and just stop it. And then you'll use this script. And as you can see, there's a solution there, but we aren't going to worry about that. You'll get that after the assignment's done, after the week is done. So let's see here. There's not going to be any new libraries coming up this week either. So this week's kind of another easier week, kind of like last week was, where pretty much the assignment was in the book. So here's your starter script, right? You need to put your code in here, okay? So let's kind of look at it. So your libraries are socket and your OS, right? So the socket's going to allow you to create that socket, that connection, as we know. OS, right? It's going to allow you to interact with the operating system, and then you need to import pretty table from pretty table so that we can produce that pretty table. So you need a host name and a host, right? So host name is being declared, get host name, and then host is creating the socket where you're passing through host name, okay? I know that seems kind of redundant as you're looking at it, but just trust me, it's gonna work out a lot better for you. Host, you're gonna need to make sure that that's not this shouldn't be commented out. You might have some issues if you like now it's gonna know that. So I would just put in 127.0.0.1 or whatever your local IP is. You'll see it. It'll tell you the interface that you're connecting to on Wireshark. Okay. Then you're going to import IP address and struct. Struct allows you to reverse any different kinds of binary addresses. So as you can see here, okay. So we create a class called IP, and that's already, again, this is already created. This is the bare bones script that you're getting for this week. And so it's going to be pulling from the IP address, or, oh, sorry. Yep, we have self, sorry. So header's being created. So the header is what's going to pull from various different packets. And it's going to give you source, destination, your sum, protocol, time to live, offset ID, length, and the TOS. And what this is these are all headers that are inside of that Wireshark capture. So when you do your Wireshark capturing, if you do like a follow TCP stream, like right click on a packet and do follow TCP stream, you'll see that all of these are in there. Okay. And human readable IP addresses, because we do like those. Right, so you're going to essentially assign yourself a source and a destination and give it its name, right? So TCP, UDP, ICMP, and if you notice in the table in the display on the assignment in D2L, you'll notice how that table looks like that, right? Excuse me. So now you got your main function where you're creating your socket, you're sniffing it out, and you're binding to your host, which there's your host again. Remember, host is up here. And you're going to sniff on whatever IP is there. Okay. And then you're going to notice how capture is an empty dictionary. So now it's going to start capturing things. Okay. Goes through a for loop where it's going to reiterate over 10,000 packets. Okay. So packet, it's going to receive, and then it's going to take its headers. So it's going to notice how it has a 0 to 20, meaning it has 20 lines for headers, which is a little twice as much as it is up here. You're passing through the IP, you're creating an IP object. So IP, again, IP being wherever it's coming from, and essentially storing that. And then we're going to do a try where we're going to essentially try to resolve the protocol name. So it should be TCP or UDP. And then you're going to just print them out. And this is what's getting printed out in the pretty table. And notice how you have down here, there's your pretty table. So this is pretty much all done. The thing that you're going to have to do is, let's see. So you're going to have to print out a try statement. You're going to need to type in, what would you need to type in? You're going to need to create a new variable. So we'll call it occur. And you need to take things from the captured dictionary, which again, that's going to be things, where to go? There it is. Things are getting stored in there, right? So try capture dictionary, that needs to have, you need to take from a list. So you need to take the source, the destination, and the protocol. So if I remember correctly, those were IP object, dot source, source address. Okay, so you're taking that, and then you're taking IP object dot destination address, and then you're taking IP object address, the protocol. IP object dot protocol. Where is it? They should have it in here. What did it name it as? Protocol name is, oh wait. Destination, oh wait, oops, we don't need that, sorry. So now you're just doing protocol name because protocol name is going to be declared as TCP, IDP, or UDP or ICMP. So we're going to try that. And then let's say it's able to display that. Now we need to keep doing that. We need to do that for every single packet that's around. So you can, then we're going to do occur, since we just did it again, equals plus or plus equals 1. Okay. Because then we're going to keep going through it and go through it. Okay. And then I'm not gonna, this is pretty much it. Then you're gonna do except, I'm not gonna write this out, but you essentially need to have it to where it stops. So it's gonna go through that, and once it exhausts, it stops. I can give you kind of like a hint. It's already kind of in front of you. So, but that's really it. So and then it's gonna take this, it's gonna print it out. Or I'm sorry, this is gonna declare it, and then this is gonna print it out. Okay, and then it's gonna stop, and there you go. And we'll run through it. That's pretty much it. So the big part is getting Wireshark set up on your system. So as I mentioned, doesn't matter what operating system you're on, you just need to generate a little bit of traffic. There is that article that'll show you how to do it. If you're doing it locally on your system, just install Wireshark. It takes all of about 30 seconds. Again, that article that I posted shows you how to do it. Or if you want to use the VLE, which all of you have access to it, which VLE is the Cyberopolis environment, use that one. But other than that, yeah, the general overview of pen testing and pretty straightforward overview of the assignment for this week. So that's all I got. So if you have any questions, if you're watching this and you have any questions, feel free to hit me up on Discord or send me an email. My email has been kind of weird, so I would say hit me up on Discord if you can, because my email has been unsyncing from Outlook, and sometimes I don't realize it, so I have to make the cognizant notice to do it. That's neither here nor there, but you always know that you can hit me up on Discord and get a pretty good response from me, as long as it's not after hours or again, and I treat it like an email on the weekends. So before I keep ranting, the folks that are in the class currently, do you have any questions on what was just lectured?
No. Nope.
Awesome.